Hi and welcome back to the course. In this video we're going to continue and start using SQLAlchemy in our models, which we've done to some extent. We've told it the columns and we've extended DB model in our classes, but we're not yet using the power of SQLAlchemy to retrieve data and to insert data into a database. We're going to be doing just that, and you're going to love it. The first thing we have to do, however, is make sure that the create tables script creates the tables properly. Remember that our item model here has an ID column. We have to make sure before we can use SQLAlchemy to retrieve and insert data that this column exists. And so that's not been a problem because so far we have used SQLite directly. But as soon as we start using SQLAlchemy to retrieve and insert data, we're going to need the table to have the correct format. So let's go to the create tables and make sure to put in here ID integer primary key. And then all you have to do is go to your terminal and make sure to go into your code folder. So right now I'm no longer inside section 6, now I'm inside code. And here run python create tables.py. Now this goes against what we looked at before, but in order to work with SQLAlchemy, we have to create the data.db file inside the code folder. If we create it outside, unfortunately, things won't work quite as we expect the way that it is taught in this video. We can make it work, but for simplicity reasons, it's better to stick to creating the tables inside the code folder for now. And afterwards, we'll look at how to change that. It's really quite simple, but just for simplicity. And that's it. So now let's go back in, and that'll now be correct. Okay, so now that we've done that, we are going to go and start simplifying our code. I've been talking about simplifying the code for a while now. We've not really seen much simplification, so let's get on it. We've got the item model, and the first simplification we're going to do is in the find by name method. SQLAlchemy handles all of this connection to the database, all the cursor creation, hell, even the queries it can build for us. And not only that, but if we use SQLAlchemy to find data, it doesn't find a row, it automatically converts that row to an object if it can. So we're going to delete the entire contents of find by name, and you're going to be amazed at how simple it becomes to find an item by its name. We're going to return item model dot query, and now dot query is not something we've defined, it's something that comes from db.model, it's something that comes from SQLAlchemy. And now with this query, which is a query builder, we can build queries, as its name says, and we can do things like filter by name equals name. Okay, so we've got the item model, which is the class, which is a type of SQLAlchemy model. Then we say we want to query the model, and now SQLAlchemy knows we're going to be building a query on the database. And then we say filter by name equals name. So what this is doing is saying select star from table name, which is items, where name equals name. And the name, this second name here, is this argument there. Isn't that great? But it does that without us having to do any of the connecting, cursoring, iterating over rows, etc. Of course, this isn't exactly what we had before, because before we selected the first row of the table after we filtered it in order to find only the one element that matches the name. But fortunately, the query builder, which filter by is also a query builder, allows us to continue filtering. So we could technically do filter by ID equals 1 here. So we can say dot filter by, dot filter by, dot filter by, etc. If we want to filter multiple things, it's always better to do this, as we can filter by multiple arguments simultaneously. But the interesting part is that then we can say something like this, dot first. And what that does is it says select star from items where name is name, limit 1. And that returns the first row only. So this line of code here directly translates to some SQL code. And this is the SQL code that it translates to. And it also does a bunch of more things, of course. Then this data also gets converted to an ItemModel object. So what this is returning is an ItemModel object that has self.name and self.price. Naturally, because this is a class method, we don't have to use ItemModel, we can just use CLS. Okay? Now, that has been quite a change. I'm just going to go back so you can see the sort of difference that we have implemented. This is the code before, and this is the code at the end, which is pretty impressive, if you ask me. SQLAlchemy makes things really easy. Okay, now let's move on to the insert method. This insert method, all it's doing is it's saving the model to the database. Now, SQLAlchemy can directly translate from object to row in the database, so we don't have to tell it what row data to insert. We just have to tell it to insert this object into the database. And remember, this object that we're currently dealing with is self. So all we do is we say db.session.add self. And then we commit as well, so it gets saved to the database. The session in this instance is a collection of objects that we're going to write to the database. We can add multiple objects to the session and then write them all at once, and that's more efficient. But in this case, because we're only inserting one object, we're just doing the adding and the committing straight after. Now, as you can imagine, when we retrieve an object from the database that has a particular ID, then we can change the object's name, and all we have to do is we have to add it to the session and commit it again, and SQLAlchemy will do an update instead of an insert. So this method here actually is useful for both the update and the insert. So what we're going to do is we're going to rename it to save to DB, because now that's a more appropriate name. It's no longer inserting data, now it's just updating, or upserting as that's normally called. And the update method is no longer going to exist. We're going to rename it to delete from DB because that's sometimes useful. And you may guess what this is going to look like. Fairly simple, db.session.delete self. And then we commit it and that gets removed. Now, as you can see, this code has been substantially simplified, and we no longer need to import SQLite 3 at the top either. Okay, now let's go to the item resource, because now there's a bunch of things that we have to change here, of course. The ItemModel.findByName still exists, and we still have to return item.json, sadly. We cannot return the object only yet. We will learn how to do that later on. We have to rename item.insert to item.savetodb. And we're also going to change the delete method quite substantially, because now we are going to use the model to do the deletion. All we have to do is first find the item by its name. So item is item find by name. And then if the item exists, we're going to do item.delete from DB. So as you can see, that is a lot simpler. We still have to return a message just so users of our API know that the item has been deleted. And finally, we're also going to update the put method to make it a bit simpler. The first thing we want to do is we are going to get rid of this updated item there. And then we're going to do the following. If the item is none, then we want to create the item. We want to save it to the database. Okay? So what we're going to do is we're going to say, if the item is none here, we are going to say that item is ItemModel with the name and data price. So we're essentially, because this found nothing, we're just creating a new one and calling it the same. And if the item did exist, then what we're going to do is say item.price is data price. Because this item is uniquely identified by its ID, that means that all we have to do at the end is say item.saveToDB. And SQLAlchemy will update if the price has changed, or it will insert a new one if there wasn't one there already. Of course, at the end, we have to return item.json. Okay, so a bunch of changes that we've made, and we still have to make one more. We're not going to touch the item list yet, but in the app.py, we have to now tell SQLAlchemy where to find the data.db file. So we're going to tell it just that. app.config SQLAlchemy database URI is going to be the following, and this is important: SQLite : //data.db. Okay, so what we are saying is that the SQLAlchemy database is going to live at the root folder of our project. Essentially exactly the same as it has been done. Nothing is going to change in terms of how we run the files or anything like that. SQLAlchemy with this code is going to read the data.db that we've already created. An interesting thing here, though, that a lot of people find very useful, and I do as well, is that it doesn't have to be SQLite. It can be MySQL, it can be PostgreSQL, it can be Oracle, it can be anything. And SQLAlchemy will just work. And that sounds too good to believe, but honestly, that's the way it is. I've worked with MySQL and PostgreSQL and SQLite using SQLAlchemy without changing a single bit of the code, except, of course, this line here. So that's really nice. So now all we have to do is go over to Postman, and we're going to be trying things out, see if everything works. So let's first register. And it does help if your server is running. That is usually required. Let's register. And it says we've registered successfully. We can authenticate successfully. And let's try to create an item. And there we go. Created. One of the tests has failed though. Response time is less than 200 milliseconds. So as you can see, slightly slower than before. And that could be due to some SQLAlchemy and SQLite slowness, or it could just be due to SQLAlchemy being slightly slower than writing things to the database directly. But don't worry, because it does get faster if everything's deployed nicely and if you're using a non-SQLite database, which is a bit slower. Okay, so everything seems to work, which is pretty nice. We found a bug here. Item has no attribute find by name, so we may have messed something up in the model, in the resource here. And yeah, the delete item.find by name, that should be ItemModel.find by name. Easy mistake to make. Let's go back to Postman. Try again. Remember, your app restarts automatically, and if it doesn't, you can restart it manually in the terminal, and there's the item deleted. Notice how the database stays there, and all the items stay there when you restart your app, because now this is persistently being stored on the disk. So everything seems to work, barring that one minor bug which we've just fixed. So we are ready to move on to the following videos. And do remember that we've only modified the item model to use SQLAlchemy. We still have to do the same with the user model, and we still have to do the same with the item list as well. So there's going to be a few more things to change here. So that's it for this video. Thanks for watching, and I'll see you on the next one.